Hello, welcome to this walkthrough of question 2 from the mechanics exam. Let's first have a look at the question. We've got an overhanging pulley system here. All the information is here. Let's just look at the key bits. This ball is 0.8 kilograms. That surface is smooth, so there's no friction. That's crucial. This is 0.6 kilograms. And we've got these distances here, 1.5 meters to the pulley, 0.4 meters to the ground here. Those will be useful in part B. The ball does not rebound when it hits the surface. And naturally, for any model at A level, this is going to be a smooth pulley. Let's have a look at the first part. Okay, let's have a look at part A. We're going to show the acceleration of Q as it falls is 4.2 meters per second. Well, let's just set up the model. We know for P, we can say the tension, which is going that way, got tension going up there. So we've got tension towards the pulley. Well, the tension must be 0.8A. There's nothing working against the tension there because it's a smooth surface. What about Q? Well, we've got gravity. We've got 0.6 G. That's your gravity working against the tension. So the tension's trying to stop it coming down, shall we say? That's so all equal to an overall force there of 0.6 times A. Well, let's add those together. If we add these two together, we get the t's cancelling out, t plus negative t. We have 0.6 G is going to equal 1.4 A. So A is going to be 0.6 G over 1.4. And if we allow for G to be 9.8, that gives us exactly 4.2 meters per second squared, as required. So let's be clear on this question what we're after. We're after setting up and accurately doing these two equations. One for P, one for Q. Adding them together. Eliminating T. We don't need the tension. We don't need to know what it is. We just know it's equal here and here because of the smooth pulley and the inextensible string. And we just need to eliminate T and work out A. Okay, let's look at part B. Now we're going to split this into two parts. The ball will move 0.4 meters under the acceleration of 4.2, which we worked out from the previous question. Then Q will hit the ground, and there'll be no more tension in the pulley. So there'll be a constant speed over 1.1 meters. So I'm going to split that into journey A and journey B. So let's look at journey A. Journey A is for the first 0.4 meters. And at that point, both Q and P are accelerating at 4.2 meters per second. So let's go for S equals UT plus a half AT squared. Well, we're going 0.4 meters. U is 0, so ut is 0, plus a half times 4.2 times t squared. So that gives me t squared, or t squared is going to equal, well, 2.1 t squared is going to equal 0.4, and we say, okay, t squared is 0.4 over 2.1. So the first t for the a bit at least, is going to be, let's look at this on the calculator, 0.4364 seconds. I've just done that to 4 significant figures. Now let's look at B. Now after Q hits the ground, there's no more tension, so P is just going to go at a constant speed. There's no force on it and there's no force against it because it's smooth. So let's work out what that speed is. So I'm just going to say, okay, V equals U plus AT. I'm just out of space here, so I'm just using the same line. Shouldn't really do this. U was 0. I'm just finding the speed at this point here. I'm finding the speed at that point after the 0.4. So V equals U plus AT, 0 plus A, 4.2. And I've got my T from the first answer, 0.4364. So V would equal, let's check this, 1.833. So I can then call that U in the next part, I think. So we want to work out, well, what's the time? Well, we can simply use speed equals distance over time, really. But it's not speed, it's a velocity. Let's say, let's go back to black for this one. So the time taken is going to be the distance or the displacement over the velocity. So that's going to be 1.1 meters divided by 1.833. Okay, let's have a look at what the time should be just for B. Just call it TB. What have I got there? 0.6801. So I've got these two times here. Time A is for this bit while it's accelerating until Q hits the ground, and then it's going at a constant velocity. There's just one direction, so velocity and speed are interchangeable somewhat here. And that velocity is 1.833. So it goes 1.1 meters at 1.833 meters per second, which renders a time of 0.6801. So what's our total time? Let's put that in blue for a treat. Total time equals 1.04 seconds. Let's be really clear, that is made up of two sections. It's made up of this bit while it's accelerating, and then this bit at a constant velocity. Okay, we often stick one of these at the end of a question. Let's look at a limitation. Well, what's a limitation? Well, let's go for this one. The model assumes that the pulley is smooth. Well, It would not work. With a non-smooth pulley. The maths would be different. And there you go. Okay, I hope that's all clear. Thank you very much.